A seesaw is a very common example of a machine called a lever. So a seesaw, we all know, moves up and down, and it's great fun to play on one, but it moves up and down in a special way. In this little model, the middle part there is called the pivot, and then this beam pivots around the center. So when we move up on one side, the way it works is it moves down the same amount on the other side. Well, that's part of why these things are so much fun. Even grandma likes playing on a seesaw. So here we go, up and down, up and down. What would happen though if the seesaw could rotate all the way? Well, now it's behaving like a wheel. Not a complete wheel, but it's moving round in a circle. The path it takes is called a curve. So really, a seesaw doesn't just move up and down, it moves up and down in a curve. Right, here we go. When you get onto a seesaw, the seesaw gets pushed down by your weight. So the other end lifts up. So a force moves a lever. You're providing the force. Now when you get down to the bottom, your feet can touch, so you can push with your feet and then push back up the other way. Well, it's more fun if there are two people involved. So you can push up and down and make the seesaw go. But what would happen if we modified the seesaw, made a change to it? Well, for a start, what we could do is take the pivot and put it in a different place. Well, this looks a little bit strange. Here we go. Move it along. There we are. Now here's a question. That person there is obviously staying, it is well out of the way, but this person here is nearer to the pivot. So that one's further from the pivot, that one's nearer to the pivot. Who gets the best turn? So which end would you be on to have most fun? Well, probably the end that moves the most. So let's just experiment. Let's move this end a little bit. And what you notice is the opposite end moves a lot more. Now, if you wanted to, you can actually compare that using rulers. So we could put the rulers in position and then say, right, let's measure how far it moves down on this side and then how far it moved up on that side. So I've got both rulers about in the middle there. Let's have a look. Now, if I was to move this one down 5 centimeters, let's have a look. 1, 2, 3, 4, 5. There it is. That's about there. 5 centimeters. Well, this one's moved an awful lot more. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 centimeters. So the person on this end gets the best ride, and the person on that end might be a bit disappointed. Well, most of the weight of the seesaw is now on that side, so this would be a seesaw which was very difficult to operate. The person on the other side would have to push to get it to move and wouldn't be able to push it very far. So this person would have to push. So it wouldn't work as well as a normal seesaw. Well, let's make it even more extreme. So what happens is, I'll move the whole seesaw along a bit so you can see it. Now that person's on there, but look, we've moved it right to the end. Here we go. Now you haven't got very much to sit on this time, but if you could, and if your partner was sitting on the other end, well, as soon as you climbed on this end, whoosh, the seesaw would fly right up in the air. So let's have a look at that. There it is in the bottom corner. You're on that end, your partner goes on that end, whoosh, and I think you'd probably fly out of the playground over the fence. So when we move the position of the pivot on a lever, it alters dramatically how the lever moves. It always moves in a curved path, but it alters how much it moves. So altering the position of the pivot from the center to further out from the center makes it uneven in the amount it moves. So Levers, seesaws aren't the only examples of levers. There are all sorts of examples of levers, and you should just look around for them. Try and find out what the part is that stays where it is, but allows the other part to move. When you think of things like a door handle that you turn, when you think of things like a door that opens or a window, they're all examples of levers, and there are countless others. See how many you can see around you, and try and name them. So that's our little explanation of levers. Fantastic.